So we'll start out. Hey Scott, what's up? We'll start out. Does anybody have any questions on the homework from last class with the mixture problems and solutions? That's sometimes a tough one for people, so I want to make sure I give you a chance. Okay, so just to let you know how we're going to handle next week, Schwamigan's out next Monday for, I don't remember exactly what it is, but they're not in session next Monday. So what we'll do on Monday is we'll do kind of an enrichment thing. It's a little bit beyond what we normally have in the course. We'll do a little bit extra on Monday. Wednesday we'll have our regular class. Friday of next week, it sounds like all of you are out of session, so there won't be class next Friday. But other than that, we will have classes Monday and Wednesday. We'll just be doing some kind of extra stuff on Monday. Okay, with that then, our new stuff starting today. We've looked at solving equations and dealing with equations. Today I want to take a look at some other forms of equations that we haven't discussed yet. We'll start out with this one, which is actually pretty simple. Not much different than the ones we've discussed before. X over 7 equals 3. And if you think of it just like that, as x has been divided by 7, well then this is no different than the ones we did on Monday. To solve it, we're just going to multiply by 7 to take off the dividing by 7. Multiplying by 7 on the other side gives us 21. So x is 21. And in many cases, thinking of it in that way, as being just the variables divided by 7, is the simplest way to solve it. But there's another way you can view this. X over 7 can also be thought of as 1/7 x. And in many cases, that's an easier way to think of that notation. So this would become 1/7 x equals 3. And to solve it, we would divide by 1/7. Now, 3 divided by 1/7 is going to be 3 times 7 over 1, which is still just 21. The reason I show you that, however, is we're going to run into some problems like this. X over 5 plus x over 8 equals 26. One of the ways we could approach this problem is as we just showed you. X over 5 is really 1/5 x. X over 8 is really 1/8 x, and that equals 26. From here, we're going to combine the x's. Just if we had 3x plus 5x equals 24, we would add the 3x and the 5x over here. Well, we're going to do the same thing here. 1/5 x plus 1/8 x. We're going to have to add the 1/5 plus 1/8. If you have the fraction calculator, you can do this really quickly. Otherwise, doing it by hand, we need a common denominator of 40. So we 8/40 and 5/40 for 13/40, which means this combines to be 13/40 x equals 26. From there now, all we have to do to solve is divide by 13/40. So x equals 26 divided by 13/40. We'll make it 26 over 1 times 40 over 13. 26 and 13 cross cancel to give me 1 and 2. So 2 times 40 is 80. 1 times 1 is 1, of course, so that's just 80. So x equals 80. We're going to come back to problems like that after a bit. We're going to look more at problems like this. Now again, this looks ugly because of the fractions in it, but it's no different than having something like 2x minus 7 equals 11. To solve this, we would add the 7, and then we would come back and divide by 2. So on this one, we're going to go ahead and add the 2 and 1/4. So we're left with 3/8 x equals 5.5 plus 2 1/4. You could find the common denominator if you want to. At this point, I'm just going to see it. 1/2 and 1/4 is 3/4, so that's 7 3/4. And then, of course, you're going to divide by the 3/8. So x equals 7 3/4 divided by 3/8. Well, we have to do two things. First, the 7 3/4. 7 times 4 is 28, plus 3 is 31/4. Divided by 3/8 means times 8/3. We'll cross cancel the 4 and the 8 to give us 1 and 2. 31 times 2 is 62. 1 times 3 is 3, which is 20 and 2/3. We can mix in something like this. So here, again, it looks a little bit ugly, but it's just the decimals now instead of whole numbers. Process is going to be exactly the same. First step, subtract 3.6. 2.1x equals 4.2. Divide by 2.1. X equals 2. And we could even have some quite a bit more complicated questions than that. We might have 3.8x minus 2.5 equals 3.1x plus 4.4. 4.4. So in an equation like this, as always, we find the equal sign. We identify where the variable is, and we find, in this case, the variable appears once on each side of the equation. So we have to get rid of one of them. So we will get rid of the smaller one, being the 3.1. So subtract 3.1x. That is gone. Leaves us with just 4.4 over here. We must subtract 3.1x from the other side. You can only take it from the 3.8x. So 3.8 minus 3.1 is 0.7x minus 2.5. Now we're going to solve it by adding 2.5. So 0.7x equals 6.9. And then we'll divide by 7. Or 0.7, I should say, not 7, by 0.7. So x equals 6.9 divided by 0.7 is going to be 9.857143 approximately. Or 9 6/7 if you want to look at it that way. So anyway, they get progressively more difficult from there as well. We can run into equations like this. So now in this equation, again, it comes down to this fraction bar here and what that means. Remember, when we were doing order of operations, that meant we had to do everything on top first, then everything on bottom, and then divide. So the last thing that was done in building this equation was to divide by the 2. So to take it apart, we have to start by multiplying by the 2. So 4 times 2 is 8. On this side, all it does is removes that dividing by 2, so we have 3x minus 13. From here, we'll add 13. 3x equals 21, and divide by 3. X equals 7. Those types of equations can get a little more complex. Like this. So here, again, the last thing that was done in building this equation was dividing by 3, but we see the parentheses. And as always, parentheses should always draw our attention first. There's nothing we can do inside the parentheses, but we can do the 5 multiplying the parentheses. So let's do that first. 5 times x is 5x. 5 times negative 8 is a negative 40. So that becomes 5x minus 40 over 3 equals 10. From there, now we can multiply by the 3. 5x minus 40 equals 30. Adding 40. 5x equals 70. And finally, divide by 5. X gives us 14. And as just like any of our other equations we did earlier in the week, we can always come back to the original equation and we can test it out. Put 14 in for x. Will this be true? Does this equal 10? Well, 14 minus 8 is 6. 6 times 5 is 30. 30 divided by 3 is 10. So it works out. Let's get a little more difficult than that. Let's try this one. So in this one, of course, the big difference is it's fractions in there instead of whole numbers again. Process is still the same. Multiplying by 7/8, we'll get rid of the 7/8. We're left with 2/3 x minus 1/4 equals, over here we have to multiply by the 7/8 yet. The 4 and the 8 cross cancel to give me 2 and 1, so it's 7/10. And now we're going to have to just go through the steps. We're going to add the 1/4. So 2/3 x equals, so 7/10 plus 1/4. We have to find a common denominator, which will be 20. 10 times 2 is 20, so 7 times 2 is 14. 7 times 5 is 20, so 1 times 5 is 5. 14 plus 5 is 19/20. So 2/3 x equals 19/20. And now we're going to just divide by 2/3. So x equals 19/20 divided by 2/3 becomes 19/20 times 3 over 2. Is 57 over 40, 1 and 17/40. Again, you can test that back in there if you want to. I will leave that up to you. One last example I want to show you of those complex equations. Actually, a couple of examples, but then we'll look at a couple of little things quick. So anyway, let's go back to the one we looked at earlier, where we had x over 5 plus x over 8 equals 26. We solve this one by turning it into 1/5 x plus 1/8 x equals 26. There's a method to solving this that many of you may have seen that for some is easier, for others is more confusing. And what it is you're looking at the denominators, the 5 and the 8, and you're coming up with a common denominator. The least common denominator here would be 40. So I'm going to multiply the whole equation by 40. So I have 40 times x over 5. So if I treat that as 40 over 1, 40x over 5 is just 8x. I'm going to do 40 times x over 8. Again, 40 over 1. 40x over 8 is just 5x. 40 times 26, I believe is 1,040. Let me double check. Yes, it is. And now we have that equation is changed into 8x plus 5x equals 1,040. And for many people, even though the numbers are getting kind of large, it's much easier to solve in this form. 8x and 5x make 13x, which is 1,040. And we divide by 13. So x equals 80. Now the reason I showed you on that one is, even though this one could have been, I think, solved easier as the 1/5 x plus 1/8 x. Working with fractions to me isn't near as bad as working with really large numbers, but you may have your own preference. But there are some equations that you have to use that method of finding that least common denominator and multiplying. For example, we might run into this. So dealing with this one, first thing we need to do is find a least common denominator. We have 15, 9, 6, and 3. Well, the 3 doesn't affect anything because all of these numbers can be divided by 3, so we don't have to worry about that. So we have to worry about the 15, the 9, and the 6. Well, they won't go into 15. 30, 6 will go into 30, but 9 won't. 45, 9 will go in, but 6 won't. 60, nope. Looks like 90 is going to be our least common denominator. So we're going to multiply this whole thing by 90. So we have 90 over 1 times 4x plus 3 over 15. Now, whenever we do this, we need to make sure we put parentheses above this number or this expression on the top of that fraction. Remember, that fraction bar means you have to do everything on top first. So even though they're not normally written, those parentheses are there. So now we can cross cancel here with the 15 and the 90 to give this a 1 and a 6. But now this 6 is distributed through the 4x plus 3. So 6 times 4x is 24x. 6 times 3 is 18, so plus 18. This next one is a little bit tricky. This here is already being multiplied by something because that negative in front. That's negative 1 times that whole thing there. So what we have here is we have 90 over 1 times negative 1 times the 2x minus 3 over 9. So I'm going to rewrite that. I'm going to multiply the 90 times the negative 1, so it's going to be a negative 90 over 1 times my 2x minus 3, I'll put in parentheses, over 9. And we'll cross cancel the 9 to be a 1, and the negative 90 be a negative 10. So now we have negative 10 times 2x is negative 20x. Negative 10 times negative 3 is a negative, or positive, sorry, 30. That brings us to our equal sign. Well, on the other side of the equal sign, we still have to multiply everything by 90. So this will be 90 over 1 times 6x plus 4 in parentheses over 6. Still cross-canceling, 6 to be 1, and the 90 will be 15. And we distribute 6 times 6, or 15 times 6x is 90x. 15 times 4 is a positive 60. And finally, we have 90 over 1 times the x over 3. The 3 and the 90 cross-cancel to give me 1 and 30, so that's just 30x. Okay, that's a mouthful already. So next, we're going to combine on each side. So on the left side of the equal sign over here, I'm going to combine 24 and negative 20x make 4x. 18 and 30 make 48. On the other side of the equal sign, 90 and 30 make 120x plus 60. Now I have to get rid of one of the x's. 4 is obviously the smaller one, so I'll subtract 4x. So 48 equals 116x plus 60. Subtracting 60. Negative 12 equals 116x. And my last step would be to divide by 116. So x equals negative 12 divided by 116 is negative 0.103. Or if we wanted to have it exact, instead of having a rounded decimal, put the negative up front, 12 over 116. Both can be divided by 4, which gives us 3 over 29, so negative 3/29. Okay, so enough for solving equations. Our next step, we need to be able to manipulate these equations without numbers in them. So we've looked at a lot of equations like this. 3x plus 5 equals 7, or whatever. And we went through the process. You'd subtract 5 divided by 3. But what if there weren't any numbers in it? What if it was just ax plus b equals c? And you're asked to solve that for x. In an equation like that, since everything is a variable, you do have to specify which one to solve for. So solving for x. It's the exact same thing as we're going to do we did over here. Here we would subtract 5 and then divide by 3. Do the same process here. So we're going to start by subtracting b. So that b is gone, leaving us with ax. The difference is when we try to do c minus b, we can't really combine them, so that just stays in symbols c minus b. Now we have to divide by a. So the a is gone, we're left with just the x. C minus b over a is just c minus b over a. Why would we care about that? Well, there's a lot of times that we have a formula that we're going to use that we need to be able to solve over and over again, but not necessarily for the variable that's already solved it. A simple formula, area is equal to length times width. Let's say we have a lot of rectangles where we know their area and their length, and we want to find their width. So rather than plugging in the numbers and solving the equation, we can rearrange the equation to get w. To get w by itself, we have to get rid of the L by dividing by L. L multiplies w, we divide to get rid of it. A divided by L, of course, is just A divided by L. That's a pretty simple example. Let's look at this one here with a power formula. Power is equal to the current squared times the resistance. So in a problem like this, if I want to solve this for the current, for I, to get I by itself, I has been squared, and then it was multiplied by R. So to take it apart, I have to divide by R. So that gives us P divided, P divided by R equals I squared. Then to get rid of the squared, we're going to square root. Making sure that the symbol covers the whole thing there, P over R equals I. So I'm going to trust you guys have done enough algebra that you can manipulate formulas like that without too much trouble. If you haven't, let me know and I can go over more of those on Monday. The last topic we want to cover for today is dealing with expressions. A simple expression from geometry is the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. So if I want to find the perimeter of a rectangle, if I'm given that the length is 17 inches and the width is 9 inches, I can just plug them into this formula here. So I replace L with 17 and W with 9. 2 times 17 is 34. 2 times 9 is 18. And then we add 34 plus 18 is 52. So the perimeter is 52. Or you might have temperature in degrees Fahrenheit is equal to 9/5 times our temperature in degrees Celsius plus 32. This is actually the formula for converting from degrees Celsius to degrees Fahrenheit. And we might be given that degrees Celsius is 30 degrees. So let's plug that in. Replace C with 30. Nine-fifths times 30 is 54. Plus 32 is 86. So that is 86 degrees Fahrenheit from 30 degrees Celsius. Let's get to a couple of formulas that are more applicable, going to be used a lot more for you guys in the medical fields. One is your weight in kilograms is equal to 2.2 times your weight in pounds. Or sorry, wrong way around. Your weight in pounds is equal to 2.2 times your weight in kilograms. It's definitely a Friday. So you have a patient who comes in who weighs or has a mass of 40 kilograms. And you want to figure out what would that be in pounds. So you're going to plug in 40 for K. Well, 2.2 times 40 is 88. So that patient weighs 88 pounds. These formulas can also go the other way. So pounds is equal to 2.2 times the weight in kilograms. Let's say you have a patient that comes in that weighs 198 pounds and you want to know how many kilograms that is. Well, we can put the 198 in over here for pounds. And we're just going to end up solving the equation. Dividing by 2.2. K equals, oh, what is that? 45? No, that's not right. 90 kilograms. So that patient weighs 90 kilograms. So that's a formula that gets used a lot because now most patients come in, if you ask them their weight, they know their weight in pounds. We need to find their weight in kilograms. For most medications are now given in dosage per kilogram. So as we were doing with the other ones before, this is a formula we would really like to rearrange so that we could find the kilograms from the pounds without having to solve an equation. So to get K by itself, we're going to divide by 2.2, which tells us that the kilograms is equal to pounds divided by 2.2. It doesn't look like much, but this formula here is a lot quicker and more user-friendly than dealing with solving an equation. Okay, the next one I want to show you, the formula for BMI is equal to a person's weight in pounds divided by the person's height in inches squared times 703. So let's say that we have someone coming in who weighs 140 pounds and has a height of 5'6". So first we gotta do is make that into inches. 5 is 60, that's 66 inches. So this is going to be 140 over 66 squared times 703. So if I were solving this by hand, this fraction bar, of course, tells me I have to do everything on top. There's nothing to do on top there. And then do everything on bottom. So 66 has to be squared, giving us 4356. Oops, times 703. So now we go ahead and just divide that. 140 divided by 4356. Oops, that didn't work. And then times the 703. So 22.59. So approximately 22 or 23 is the body mass index of that particular patient. let's do one more example of that at least. Let's take someone who is 250 pounds and is 6 foot 1 inches tall. So again, this immediately is going to get changed to 73 inches. So our formula will be 250 over 73 squared times 703. Now last time I did it by hand, I squared this number on bottom here first. We don't necessarily have to do that. Our calculator can handle this all at once. 250 divided by 73 squared. And then times 703. Giving us a 32.98 body mass. So a 33 body mass index, which is getting pretty high. Next to that, probably the most difficult process to do in math is to take a word problem, a set of words, and put it into symbols. So I want to do an example of that before we call it a day here. I'm going to do a pretty simple example, and we'll do more and more word problems as the semester goes on. Let's just say the charge to rent a CPM machine. CPM stands for continuous perpetual motion. It's for joint replacement surgeries or many of your joint reconstruction surgeries. It's a machine, for example, if it was a knee or a hip, you'd lay your leg in the machine and it would keep it moving for you so that the joint didn't seize up from the surgery, the scar tissue didn't seize up the joint. So the charge to rent a CPM machine is $200 plus $80 per day. How many days can the machine be rented if insurance has a limit let's say insurance has a $760 limit on the rental. So our first step here is to write the equation. The charge for renting the CPM machine is $200 plus $80 per day. So plus 80 times D. Now that we have the equation, we've put in the information we're given and we solve for what we're being asked. We want to know how many days. So we're solving for D if there's a charge limit of $760. So that goes in for C. So rewriting this as 760 equals 200 plus 80D. Subtracting 200 is 560 equals 80D. And we can divide by 80. Get 7. So we can rent that machine for 7 days before the insurance will run out. Okay, that's pretty much all I have for today, so I'm going to give you some pages to work on. In your book, pages 60 through 61. There's 1 through 47 the odd, and then jump up to 61 through 65. Then on page 67 through 68, we are looking at 1 through 27, the odds. And also, oops, I forgot to list them there. Also on those, I'd like you to look at number 35 and 37 as well. So that'll give you pretty good practice with manipulating the equations and solving more difficult equations. I realize most of you have had algebra and probably algebra 2, so you're probably pretty familiar with it. To give you an idea of how our schedule is looking, just so we don't have any surprises. Like I said, next week we only have really one real lecture, so we will go through that. What do I got here? Talking about ratios and percents most likely next week. Then the week after that we have, that's our first full week of lecture there. So we're about, oops, where are we? We're about 2 weeks from today away from our next test. So that would put us approximately what? Either February 27th or March 2nd. I'm probably looking more towards March 2nd as our next test. So just so you're forewarned. With that, I'll call it a day.